Okay, so we are going to start with the second session. And just to wrap up and set the stage for the next talks, what were the take-homes in terms of leaf area and their carryover effect in terms of fruit? From a winemaker perspective, we've been looking at the plant, at the leaf area, at the root, at abiotic stresses. And that's where it starts to get even more complicated, because sure, we have some hint pointing at the fact that there is a carryover effect of nitrogen from season 1 to season 2, and there are many more carryover effects that do exist, and that points towards the negative side of not having enough nitrogen. However, having some slight and moderate stress in terms of nitrogen supply is actually good for anthocyanin. So not enough is not good for the leaf area, too much is not good for the fruit compositions. There is a sweet spot to find in terms of maneuvering nitrogen deficit. The same goes on for water deficit as well, since it affects the anatomy of the berry. The berry size is reduced with water stress, but also the anthocyanin content. On top of that, as we've seen temperature getting warmer, the question of when am I going to get into my optimal window for triggering harvest is difficult to answer for various reasons. First of all, is it true or is it not true that there is relationships between an earlier leaf area development and an earlier onset of sugar accumulation? Maybe reproductive and vegetative stages are not so related with one another. The second thing is the date of veraison is for sure driven in large part by heat accumulation, but not only. Actually, there has been new papers showing that the crop load is impacting veraison. The higher is the crop load, the more delayed is veraison. And last but not least, and it's actually maybe the most important thing in the context of warming of the temperature and more arid conditions, 3 compartments of the fruit, the seed, the pulp, and the skin, are now showing that they do mature at different rates, which points towards the fact that we need to specifically investigate fruit composition for those 3 different compartments. And hopefully, Simone Castellarin and Jim Kennedy are going to shed some light on what we understand about differential maturation rate. So just before diving into period 3, I wanted to get some insight as far as how the water deficit in the atmosphere impacted fruit composition, because one of the main take-home since we've been doing those vintage conferences is that it's the deficit in water vapor in the air often that cause visual appearances of stress, is not so much the deficit in soil moisture. So because of that, the footprint of a vintage is heavily driven by the frequency of heat wave, particularly during the pre and post veraison stages. So here I bruise through the frequency of heat waves during the period stretching from bud break until, roughly speaking, the end or the slowing down of sugar accumulation. And what makes 2015 interesting, at least during leaf area establishment and the first stages leading to primary metabolites accumulation, is a lower frequency of vapor pressure deficit. There were less heat waves. There were actually 8 heat waves less in 2015 compared to 2014 in that time frame. So it's rather a good sign, because we know that every time we have a heat wave, it disturbs the hydraulic properties of the plant. We often see some stop and go in sugar accumulation, and the lower is the amount of heat wave, typically the smoother are the accumulation profile of sugar. So on paper, having had 8 less shriveling events is rather a good condition to set the stage. But how did it really affect fruit composition? The next slide is actually going to discuss with you how 2015 is different, I expected it to be slightly sooner than 2014, given the fact that the vegetative development of the plant was also sooner. But when we looked at the statistical trend of all the blocks that we've been monitoring, it's not exactly the picture that emerged. Here, each line is the result of a statistical analysis of a big cloud, a big potato of data that help us understanding here the rate at which sugar accumulated into the berries. I choose to show sugar per berry so that we are not getting fooled by the footprint of heat wave at increasing bricks due to water losses out from the berry. So really, by looking at sugar amount per berry, we can see at which speed sugar was actively loading from the leaves into the berry. And the first point that was striking to me is, number one, in spite of having had an earlier leaf area development, you see that the offset between the green curve, which is 2014, and the blue curve, which is 2015, is not pointing in the same direction. Actually, 2015 is lagging slightly behind 2014, which shows that no, there is no a tight relationship between the onset of vegetative development and the onset of the reproductive development. So that's the result number one. The second thing is that we observe very well that 2015 actually was more mimicking the speed of sugar accumulation that we observed in 2013. The black and the blue lines are actually overlaid. And another thing, we observed for sure a smooth profile in 2015, but the peak of sugar accumulation, you see this peak here, is reached slightly earlier. And it's not a surprise to also observe that the maximal amount of sugar per berry is around 240 milligrams on average, which, all things considered the same over the last 4 years, is the smallest peak, which makes sense since we know that water deficit pre-veraison, you remember the slide just before the break, is slightly more severe, which in turn should have driven slightly smaller berry volume, and a smaller berry can only hold a smaller amount of sugar. So there is a good articulation between the vegetative pictures in terms of water stress and its consequence on primary metabolite. But that's not it, because we don't harvest according to when the peak of sugar accumulation is being reached anymore for the impact of warming of the temperature. In the past, it was fairly easier since as time unfolded, we knew that the plant was set to first reach its peak berry weight slightly before the peak of sugar in terms of concentration or in terms of sugar amount per berry was reached. And then we knew that the window for aromatic profile and polyphenolic profile were happening very soon after. So it was actually a good idea to track primary metabolite to infer the consequences of accumulation of sugar, degradation of acids on aromatic profile development and polyphenolic profile development. However, this is no longer true. There is a ton of research being done now that points towards this global trend, which is worldwide. We observed a disconnect. Scientists speak of a decoupling or asynchronism, whether you look at papers from Australians or Italians or anywhere in the world, and they all point at the same thing. In the context of warming of the temperature, there is a disconnect, there is a decoupling between the blue box, which shows how early sugar reaches its peak, and the timing when aromatic profile and later on polyphenolic profile will reach its peak. So in order to better grasp how environmental conditions are actually affecting this time gap that gets wider and wider between those three different maturation windows,